Hi, welcome to this edition of Location Filmmaking, and this time we're going to be talking about sound, and especially how sound affects things in your film. Let's talk about basic fundamentals of sound first. I'm just going to go briefly, but you should already learn this in your sound classes. But we'll be talking also a little bit about microphones, but most importantly, we'll be talking about the aesthetics of sound in film. So let's look at the basic fundamentals first. Sound actually travels in waveforms or through a series of vibrations that requires air to go from one place to another place. And as it goes, there are certain pressures that actually exert from the original source, and it travels at 343 meters per second. So it's pretty fast. We measure sound by the measurement of hertz, okay, and that is expressed in the terms of cycles per second. So the fewer cycles per second, you have less hertz. The more cycles per second, you have higher hertz. So the range of sounds that comes from your microphone, especially a very good microphone, we sometimes measure it signal to noise, or we actually ask about the frequency response, and that is the range of sound that the microphone can pick up and reproduce it to the human ear. So if you have a microphone that's very cheap and the frequency response is very low, that means it may not be able to pick up very high sounds and may not be able to pick up very low sounds. All right, so the frequency response is very important. Typically, we want to be looking for the magic number 20 to 20,000. Okay, this is the area that a human ear can really respond to. Now, when I say respond to, it doesn't mean that we can purely hear all the way. Okay, we can hear some of it unless you are like Superman or anything like that. You might be able to hear beyond the scale, but this is kind of measured that we can kind of hear roughly around this range. So a typical test is this. Okay, I'm going to start this test with a signal frequency of 20 Hertz. This is like bass. When I play this clip, you're not going to be hearing it very well, but you might be able to hear something. So as the frequency gets higher and higher, it will tend to be more audible. Here we go. See, now you can hardly hear it, but now you can still hear something. Now we're going to 29 rate, 30, 40. So even if you buy a pair of headphones that can hear 20 to 20,000, may not be able to hear up to 20 Hertz, all right? You might hear up to about 30 to 40 Hertz. So now we are at 80 Hertz. And as the frequency cycles get more and more per second, you notice that it pumps up on a higher pitch. And you may not be able to take up to 20,000 Hertz because it will most probably kill your eardrums. So, roughly about 300 plus could be roughly the limit that people might be able to withstand before they kill themselves, right? Okay, so all the sound waves that you hear, in terms of the height of the sound waves, the loudness of the sound is measured in decibels, right? That's dB right here, that's the units. And in order for that to occur, the height of cycle, we call it the amplitude. Or in simplification, in order for you to receive the cycle of height of the noise, that means in terms that we can actually hear something, you need to have something to give you amplitude. Therefore, when you go to an audio shop, people sell you amplifiers. All right, these are machines that give you amplitude of sounds. So what is a decibel? Okay, so let's see, decibel.
Does anyone know what a decibel is?
You know, who know?
Tell us, Mr. Audio.
After Alexander Graham Bell invented the telephone and telephone lines began to be strung up all over, the bell, spelled B-E-L, was the loss of signal strength in 1 mile of telephone line. A decibel is then 1/10 of that. A microphone output is generally in the range of -65 to -85 dB. Line level, the signal level that audio devices operate, is typically plus 4 dB for professional gear, like recording consoles, digital audio workstations, tape recorders, and outboard signal processors. For consumer gear like TVs, CD and DVD players, the line level is minus 10, 14 dB lower. Generally, any analog input or output that uses an RCA or phono connector is at the minus 10 dB level. Although a 14 dB difference between professional and consumer line level may not seem like that much, remember that an increase of only 6 dB doubles the volume.
Thanks, Mr. Audio.
For more interest,
In simple English, that means how much can the equipment take the noise, the sound that travels to the cable. So if you have a cable that can only have minus 10 dB, that means once the noise hits beyond that, okay, like minus 6 and going to like plus 4, the wire will not be able to handle that sort of sound that goes through, and might end up distortion. All right, that's why a lot of people spend a lot of money on cables. Pure audiophiles who have very good sound system, they will not buy a $10 cable. All right, because the cable will not be able to handle that sort of dynamic range. All right, so sound that comes in through microphones or a recording from a music that is being played, you make sure you have the cable that can actually funnel that sound through. So dynamic range is a word that we use to describe the range of soft sounds to loud sounds that a device, especially a microphone, can handle. Right? So if someone sings in a microphone and the person shouts, and the shouting is recorded at plus 4, but your microphone can only handle at plus 2, so you are 2 times or plus 2 times beyond the range, the microphone is going to give you distortion because it cannot handle that range. So same thing, a lot of money is being spent on really, really good microphones that can handle a lot of punishment. So let's look at what dynamic range in audio is.
What is dynamic range? Dynamic range is the difference in decibels between the softest and the loudest signal a device can handle, and it's also the difference between the loudest and the softest level of an audio signal. The dynamic range of digital audio at 16-bit is 96 decibels. The average range of magnetic tape is around 60 up to 70 dB. If we're going to look at radio, an AM signal has around 40 dB of dynamic range, while an FM signal has around 70 dB of dynamic range. Let's talk about the dynamic range of music. Classical music is known for its big dynamic range because the difference between the soft parts and the loud parts is big. If we're going to look at more modern type of music, we see that we heavily compress this music, therefore it has a small dynamic range. If we're going to look at dynamic processors, these are devices which control the dynamic content of an audio signal. We use compressors, maximizers, and limiters to actually make this dynamic range smaller. There's also tools like gates and expanders which make this dynamic range larger. So there's various ways to influence the dynamic range of a signal, and this will really affect the perception of your sound a lot. If you got any questions?
So we really know that dynamic range between the soft parts and the loud parts, there's a certain range. And in this simple chart, we really know that once the sound travels from one amplitude to the other, it produces one cycle, and the height between the soft part and loud part we measure it by amplitude. So what gives you these particular sounds is microphones, and it's imperative that you know there are two types of microphones. Microphones are actually designed based on their build, whether they can pick up soft sounds or loud sounds, and based on their pickup pattern, whether which direction the sounds are coming from. So dynamic range microphones comes in two basic kind of designs: dynamic microphones and condenser microphones. So dynamic microphones, inside they have a diaphragm, and condenser microphones, inside they have a capacitor. So what's the difference between these two? So let's look at this explanation.
Hi, I'm Gary Bonds, the Marketing Director for Audio Technica, and I'm here at Sonic Electronics talking about the difference between dynamic microphones and condenser microphones. Now, although they both take energy and converted into electrical energy, so the sound of your voice or your instrument into electrical energy. The way they do it makes them sound very, very different and have different applications. In a nutshell, dynamic microphones tend to be much more durable. They handle ridiculous amounts of SPL, which is sound pressure level, and they also have a little bit of high frequency attenuation, meaning they don't tend to translate to high frequencies as well. Also things called transients, which are real fast moving, so they don't tend to pick up as well, and they tend to be a little less sensitive. Now these kind of sound like negatives, but they actually make them really good for certain things. High SPL instruments would be stuff like horns and drums and snare drum and kick drum and guitar cabinets, things of that nature. Dynamic microphones work great for. Now condenser microphones, as we've learned before, have a much lighter diaphragm. Now this allows them to have extended frequency response. They do take a little bit more care than a dynamic microphone, but they excel in studio environments. They're typically used on acoustic instruments and instruments where articulation is key, such as hi-hat and ride cymbals. So hopefully this helps you take a little bit of sneak peek between what the difference between dynamics and condensers are. But again, in any situation, you use your ear. Audio-Technica, we can just, what I say, make crayons in a crayon box in a bunch of different colors, and you decide which crayon you want to paint your picture with as the artist.
So we look at the polar patterns, the pickup patterns. We're looking at omnidirectional cardioid, supercardioid, and hypercardioid. So what are these?
Hi, I'm Gary Boss, the Marketing Director for Audio-Technica, and I'm here at Sonic Electronics, and right now we're going to talk about polar patterns, or what people call pickup patterns. The polar pattern of a microphone describes how a microphone responds to sounds from different directions. And really there are two general polar pattern types. The first is omnidirectional and the second is unidirectional. Now omnidirectional pickup means that sounds come equally from all directions and are picked up equally from all directions. And that's the front, back, bottom, side. Remember, this is a 360-degree pattern and a 360-degree pickup. Now these types of mics are used more in applications where sound is recorded rather than in live situations where feedback can actually occur. Many interview and video mics are omnidirectional when the environment is quiet, and this allows one mic to be used for two voices without having to pass the mic back and forth. Omni mics are also popular in many stereo recording techniques. Now unidirectional means that a mic responds better to sounds coming from a specific direction and having less response from others. The most popular unidirectional mic, like I have here, is the cardioid. And the word cardioid comes from cardio, referring to the heart. And you can see the little shape on a microphone. It's a little upside down heart, or some people call it a butt. This means that the mic is most sensitive to sounds coming from the front and less sensitive from sounds coming from the sides. And the strongest rejection of this mic, or the null point of the microphone, is those coming from the rear, 180 degrees off the front of the microphone. Another term associated with unidirectional microphones is called the acceptance angle. This refers to the angle that the mic will pick up best. Cardioid mics, for example, have an acceptance angle of about 120 degrees. Okay? Another popular polar pattern for live use is the hypercardioid. Now these mics, like cardioids, have the greatest pickup from the front, but have more rejection from the sides. Now the acceptance angle of a hypercardioid is 100 degrees, so it's much tighter. To gain this tighter pattern, the mics will have a small lobe of pickup right here, right in the back. This is why you need to be familiar with your mics, because putting monitors directly behind a hypercardioid is not a good idea. The null point on a hypercardioid is 110 degrees off axis. So what you do is you find your on axis and you go 110 degrees. I don't do the math, but essentially if you just do it the other way and go 110 degrees, so it has two null points right here. These types of microphones are popular for loud stages or weak singers where you need a little bit more distance. Again, a loud stage, you're going to get less spill into the microphone. The vocalist just needs to remember that they need to be right in front of the microphone. You can't be off, you're going to lose the vocalist.
So here's a sample of an omnidirectional mic. It's 360 degrees. Very good for recording 2 or 3 people standing around a microphone. This is cardioid, which is called unidirectional. You notice at the back, it doesn't have a 360 degrees. It's more going towards the front. This is kind of like the mics that we have in the cage. Supercardioid, as you mentioned, there is some rejection to the side, but there's some here at the back. Normally this sort of mics is used because they want to have some sounds that's flooding from the back to give a little bit of echo. Some of these mics are good when they want to maybe record things in a warehouse and they just need some echo stuff. It all depends on what the user wants. Hypercardioid is the same as this one, but the range is longer from the back. If you notice, there's more range from the back. So aesthetic of sounds is very, very important because you need to understand presence. That's the sound that you hear from the screen to determine how far the sound or how close the sound is, because you need to understand the perspective of the sound, the relationship between you as a viewer and your objects in the film world. Okay, whether it's the video or the audio. Because if you have someone that is running in the beach and the person is 100 feet away, the person shouting cannot sound as though that the person is beside you. It is absolutely impossible. So you need to understand that the closer the sound perspective is, your microphone also must play a part. So when you do these recordings, you make sure you choose the correct mic so it rejects sounds that you should not be recording into your film. Okay? Very simple rule of thumb: the further your subject is, the less sound it should be mixed into your film world. Okay, a simple chart like this. Okay, if someone is very near, then he should be louder. Someone that's further, it should be softer. Okay, this is a very simple thing. And your sound must be balanced in your film world. Now the trick is that you need to get the best recording of your set at all times. You cannot say that, oh, we'll try to fix that person's dialogue during editing in post. That is stupid. You should not do that. Try to get the best recording possible. Then later on, when you want to add more sounds in the scene, for example, a party sound, and you want to balance the scene to be real life, then you add all these separately. You don't collect them together. You don't do a party scene and shoot the dialogue at the same time, because when you cut from the dialogue from one person to another person, the background of the party scene will have a different sound. Okay. Next, when you place the microphone close to your sound source, like a person that's talking, or please watch out for any reverb, echo, okay, in the interior recording. Could be echo from a fridge, could be echo from the cars that's outside the house that is hitting the ceiling. So it could also be echo from your machine. If you are doing night shoot and you borrow a generator, you turn on the generator, the motor is moving. So there's a lot of sounds. You might want to put a cloth or quilt or any absorbent material to try to block out these sounds. You can also put a cloth over the window. You can put a cloth over the fridge just to block off the sound, because you're trying to get the best sound possible. Your greatest enemy when you go outdoor is wind. Okay, wind and other things you can't control, like birds. So these are the stuff of nightmares. You can reduce these sounds by placing the mic closer to your subject, your actors, so that you get more of the dialogue and less of the outside sound. These sounds will also affect your continuity. Okay, because from one shot it could be birds chirping, cut to another shot of the same place, the birds is not chirping. So that is your greatest nightmare. So if you're going to use the bird chirping sound, then you better make sure that you get some bird chirping sound to bathe over the next shot. Also, watch out for your talent that's moving closer and further from the mic, because if the person is walking up and down, you will not get a clean sound. Move the mic with your actors. Okay, watch out for background sound changes, and watch out for shot to shot different sounds from background. I'm going to show you a clip from this film called Contact by Robert Zemeckis. Okay, Robert Zemeckis is the director of Back to the Future. You should know him by now. Let me tell you how sound is being used as an introduction to this film. Watch this.
A sniper has fired at President Kennedy.
W9GFO here. Come back. CQ. CQ. This is W9GFO here. Come back.
So as you can see, the introduction started off with music from the Earth, and as we move away from the Earth, we still hear a lot of music. But the trick was that as a lot of sounds and music that we hear as we get further from the Earth were very, very old music and very, very old news announcements. That's because as time progresses and as we transmit sound, the sound reaches to the ends of the space. So as we go further into space, we will catch up with the very first sound that we transmitted from Earth because it's still traveling through space. So this particular way of introducing a film through sound is very, very unique. So when we look at sound, we also look at how consistency the sounds are. So I want you to listen to these two sounds. Try to figure out which one is from a lavalier mic and which one is from a shotgun mic. By the way, a lavalier mic is a mic that people clip on to their clothes when they're talking, and a shotgun mic is the type of microphone that you use for filmmaking. All right, so just listen. Guess which one?
My job requires me to travel all across the nation, and like most people, I prefer to travel light.
And how about this one?
My job requires me to travel all across the nation, and like most people, I prefer to travel light.
So as you can notice that this one is from lavalier and this one is from shotgun. You understand that shotgun you tend to have a little bit more echo because the mic is very close to the ceiling, and then the sound reflects from the ceiling and then enters the mic. Alright, few things. Make sure that before you go and shoot, go and do a recce, assess the sound problems from each location and each scene, and find out where you can place the mic. Think of how to get rid of any unwanted sound, traffic from the window, dogs barking, etc., etc. Place your microphones close to your sound source. In this case, your actors. Okay, get them to say something first before you roll action. If there's a scene that is shouting, please either you pull your microphone back or you reduce the volume during that time. Please, 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 I cannot reiterate this enough. Once your scene is finished, record ambient or wild sounds or atmosphere sounds from the scene. Collect 1 minute of pure silence from the scene that you just finished. because you may need the air sound, you may need the chirping sound, you may need just the sound from distant traffic just to fill in the gaps. Monitor the quality of your sound, not how much sound that you have. You can shoot 10 scenes and get 10 good dialogue, but if all the good dialogue is being soured or corrupted by dog barking, children crying, is no point. All right. So the golden rule is get it right one time so you don't have to do it another time. Go to chapter 7 to look at microphones and recorders. Go to chapter 8 to look at approaches in sound recording. Okay, read this because it's very, very important for you to understand how the professionals actually do their sound recording.